comment that Varsha is talking about, I think that was also one of the points that Derek brought out yesterday, in terms of people making comments about AI and big data, that it doesn't require data quality. And I suppose we're seeing more and more that it sort of needs more attention. And you remember they talk about the 4 V's or the 5 or 6 V's every time we get a new one. And the one V that the big data people like to call it is veracity, which actually means data quality. Yeah, veracity. Yeah, so it's data quality that we're talking about now. Those are extra ones added above the 3 V's, and so I don't see it as a 4th V, because data quality is important for all data, not just the big data or whatever we're dealing with. All right, fantastic. So we're moving on to conceptual modeling. We've had a few people reach out to us to say, can we have a sort of, not a shorter data modeling course, but a data modeling course that maybe is focused on data citizens or higher level people? And so we've been building this conceptual modeling course, and I'd love to get your feedback in terms of how you find it, and whether it's addressing all of the areas that you'd like it to address. Okay, so I'll take you through some of it. This is, as I'm presenting here, this is the learning path that we want to go through. And here you can see this is for a data manager, almost. The manager either responsible for the data management office or for the data modeling or data architecture practice. These are the areas that we are trying to address. And it goes in terms of real world challenges. What are the challenges with respect to data modeling? And then what are the key takeaways? Okay, so the type of challenges we'll deal with is stakeholder alignment. How do you get them to commit to the purpose of building a conceptual model, and not one that is done in the beginning and then disappears or never gets looked at again? It's one that will be maintained and sustainable. And then how do we build an implementation framework for those of you that are in data governance or establishing a data management practice or data modeling architecture practice? How do we build an implementation framework? And I use the term P3T. I wonder how many of you remember some of the discussions we've had, but that is your principles, policies, and procedures, and then the T stands for the technology or reference architecture that's appropriate to data modeling. Okay. Now, I suppose quite a few of you, when we asked, and maybe that's a good point to ask the people, what technology do you use for data modeling at this stage? Is it just a data modeling tool like Owen, or do you go any further in the realms of simulation or digital twins? So anybody have any experience of moving further than just data modeling? Because one of the challenges you have with data models is the validation. And Maria Kent spoke about that on Monday when she spoke about ontologies and declarative models. One of her comments was, how do we validate a data model that it is correct and it's accurate? That's got to be one of the important elements. So I've just got someone who's reached out to me on WhatsApp to say, please share the link. Debbie, that's JG. I'm hoping he gets there. All right, so P3T, that's a technology discussion. Architects should make those decisions. And there's JG. Welcome, JG.
Hey, Howard. Sorry,
yeah, good to have you here, sir. And then we have the operating model. So what are the roles and responsibilities around data modeling? Who provides inputs? Who supplies that? Who consumes the data models? The scalability of data modeling to meet evolving business needs. And I know I've had this discussion with JG quite often is, initially we do this data model to build the system, but then we should always be coming back to the data model when we make changes. So how scalable and how sustainable is data modeling? And then we talk about data integration. That's another aspect which is a real world challenge. How do we integrate data from many different sources if we don't have a model of the data or the target system that we want to go to? How do we achieve that? So those are some of the challenges that a data manager needs to address. Now, the key takeaways for data manager at the end of the day is how do you understand and explain the conceptual modeling benefits to an organization? Okay. How would you convince them that they need to do data modeling? And maybe just as a hands up, how many of you are doing any data modeling within your organization at the moment? I'd love to see that because I've noticed a tremendous decrease in the desire or the interest in data modeling. Now, I want to be able to also differentiate that from doing an economic data model or a model of like a statistical model. Okay, so it's not exactly the same as that. It's the model of the data, of the structure of the data, and how these things work together. How many of you, if you wouldn't mind just putting up your hands, how many of you are actively doing data modeling within your organization? Oh, nice, Don. That's great. Adam, JG. Oh, wow. 4. Okay, great. And Mr. Bolton, are you doing data modeling? Yeah, he's quiet. Okay, great. So how do we understand the model? Then how do we use the model? Any comments there, Paul? I see your light flickering.
No, I just wanted to say not yet.
Okay.
I was tangling with normalization this week, as you know. So
yeah, the fourth and fifth normal form.
Yeah.
JG said he can help you.
Cool, awesome.
Okay. All right. So how do we bring data modeling into data governance? How does data governance depend on data modeling? It's critical to data governance. And then what other knowledge areas depend on data models? And then strategies for effective data governance and the management of conceptual models. And then this communication is important, getting a shared understanding of what this practice is all about. Everyone needs a common understanding to communicate effectively, and writing business definitions. Okay, so that's the one we're going to focus on today. This is where I feel that all of us can benefit. This is what I mean here is the pot of gold is if you can take this away with you and understand the value of data modeling to data governance, I think that's crucial. Next week, we'll be talking about the data citizens, and this is where I feel the biggest benefit to our data citizens being a data steward or someone that's working with data is how do we use the conceptual models to make informed data-driven decisions? Okay, so that's an area we'll talk about next week, and we'll deal with the challenges of data literacy, adoption, simplification. How do we work on that? Then when we get to the data professionals, we'll be talking about advanced techniques used for data analysis. So it's the type of things that we have of data vault modeling or temporal modeling or focal point modeling, wide dataset models, and then the best practices in terms of effective models that accurately reflect the business need. Okay. And then we'll discuss a little bit of tool compatibility. How do we also link the models that we build to master data? How do we link them to data analytics and design? So when you start building your Power BI dimensional models, how do we get that right? How do we curate the models? And how do we work with wide data? How do we generate wide data for our data scientists to look at correlation, causation, and the feature engineering that we talk about when we go on to data science? Okay, and the data executive, the area that's important for him is strategic insights, insights on how to use it to drive business value and innovation. Okay, so how would we use that scenario? And I'll actually address some of that today in the last section. All right, so conceptual essential concepts, sorry, in terms of conceptual modeling. There's quite a lot to it, and I will be getting into these different forms: entity, dimensional modeling, focal point modeling, fact-oriented modeling, object-oriented modeling, time-based NoSQL modeling, and semantic modeling. I'll be getting into that with a professional. So we'll just be doing these two today. These three, sorry, and then we'll talk about all the different schemas at a later stage. Okay, now before going too far, I wanted to just talk about some important terms. And please stop me if I'm not doing a good job at describing this for you. I think it's critical that you understand these different areas. So there are four important terms that you need to, critical terms that you need to understand. First of all, it's the conceptual schema. Then from there, we can derive the concept model. From there, we go into a conceptual model and then into conceptual modeling. And sorry, I've actually got this the wrong way. I didn't come back to it. From the concept model, we do conceptual modeling. The conceptual modeling builds a conceptual model, and then it goes back to a conceptual schema. All right, so I will get to this in more detail. So I wanted to start at a very high level at what are the different definitions that I found on the website for a conceptual schema. Now, if you remember the course or the talk that I did on writing business definitions, the way I like to do it is I go and search on Google, give me the meanings or the definitions that we have different people sharing with us. And then what I do is I basically highlight the terms and I use my 6 friends. So the first one is classification. Okay, so here you can see whenever you see ISA, you already know that somebody's giving you a classification or categorization of a conceptual scheme. So Wikipedia describes it as a conceptual schema is a high-level description of informational needs underlying the design of a database. Okay, now, so that's the one definition. So the classification is a high-level description. When I look at Cambridge, it has a very different definition, and that's where I brought it in to start with. And it's based on ideas. It's a drawing that represents an idea. So you can see it's actually quite different to a database design. So we've almost got an overload of terms here. One is a drawing that represents an idea. It's easy to understand. And here is an interesting thing is to say, at the center, the conceptual schema defines the ontology of the concepts as the users think of them or talk about them. Just quickly to share with you on ontology, it really is just a study of what it means to exist. So what we'd be doing here is we're basically saying that a conceptual schema defines the concepts that exist as the users think of them and talk about them. Okay, so very important in terms of, first of all, we've got to define the who, the users that we are engaging with. they would typically be the SMEs that the data model is being built for, or the system is being built for. Okay. Now, when we get to Wikipedia, of course, it talks about a conceptual schema of a physical database. It explains where the data is stored in a database and what the data types are. Okay. And there's only one conceptual schema per database. Okay. Are there any questions, Bill? Any questions from your side? I saw a flick of light. I'm not sure if you had a question there.
No, I just dropped off. I had to rejoin.
Okay, sorry. All right, great. So now this is the next one, and a concept model. Does anyone know who Roland Ross is? Who's heard of Roland Ross? Who's spent time reading his material? He does a fantastic job. Okay, I call him Mr. Taxonomy. Now, Roland Ross is really focuses on the words that he builds, and what he does do is he actually builds taxonomies that you can load into SharePoint, and it's basically a word map of a subject area. Okay. Now Roland Ross defines it as it is an aid, okay, to achieve precision in a continuing discourse or discussion about some subject matter. And you'll see every now and again they refer to this as a universe of discourse. So a subject area is a universe of discourse. It's about a discussion. It's a discussion about an area. So let's talk about marketing could be a subject area. And then we would build a concept model and a conceptual model to represent that universe. And what Roland Ross talks about is he likes to get all of the terms defined even before he starts drawing the conceptual model. And that's why in my flow of things, I get the concept model first, and then I get the conceptual model after conceptual modeling has taken place. Okay. Now, I think this is a very important thing to take home, because when I did the writing business definitions course with Terry and Mark Atkins, I said, well, why can't I create a conceptual model first and then go and write the definitions? And Steve Hoberman sort of talks about it in that way. Okay. So they constantly come back and said, Howard, no, you can get very confused about the conceptual model if you don't have business definitions. So their preferred approach is get the business definitions right, and their technique is go and look at the dictionaries, then get these 6 friends out, then go and build your model of related terms afterwards. Okay. And I'm interested to see or ask you guys what you think about that flow. And I'm sure Paul Krobler's, I'm sure he'll have a comment on that. Paul, yes, Veronica.
Yes, I did notice that Steve had said somewhere that he actually has found it valuable to define something before he even models it. And I think that's the same thing that you've said here.
Yes.
No, and then agree with the business, the definition, and then the
yes.
model's going to have more precision.
And Veronica, that was on his last presentation, which changed from our initial course with him. And remember, he also had that term of saying the definition is it's like a Superman definition of you define by what you do. Okay.
That's Batman.
Batman, sorry. Superman, yeah. Okay. All right. So Roland Ross.
So just
yes,
you
Paul.
Called out my name there.
Yes, I'm challenging you because I'm not sure how much attention you pay to this precise definition of a term before you do the modeling.
If I think back at we're doing something like this at AGOF, for example, at the moment. But interestingly enough, they use quite a few terms that has a a kind of a working definition in the company, but they can't bid it down yet. So nobody's quite ready to actually put it down into our model and give it that definition.
Right.
But it's well defined. It's well enough defined so that you can get on with it and relate it to other things. So I'm not sure if there needs to be a hard and a fast order of how to do it. My chaos brain would say, okay, whatever works for that particular context, go with it. But what I like about the idea of first trying to define it is, I think what starts off as one thing, if you write it out, you'll quickly maybe realize you are using more than one noun in that description, which possibly means you're actually describing two things, or you're mixing up a concept and you should actually have separate things that you can rather relate, as opposed to take one term, put too many things into it, and then you're in a mess. So I think either way has merit, but I like the definition first. It's just not practical always, at least not in my experience.
Well, and so what you will find, and that's also quite a nice way of doing it, and this is Terry and Mark Atkins both come from a data warehousing background, and they found so many times that we jumped over the definition too quickly, and we created relationships that weren't appropriate or weren't as part of the business saw them. Now, when you bring it down to this level of detail, the 6 friends, you're actually breaking it up into single statements, and then you need the business to approve every statement. So they really say you can't operate in this type of definition. It's got to be 1 what per line, and you would agree it per line. So, for example, you have to agree, does it enable clear communication? Does it express sentences that can be understood? Does it allow for disambiguation? So when you have text or whatever it is, you can find the challenge with language, and specifically English, and it can be confused that you think people agree with you, but you don't. Mm-hmm. You're not in agreement. And breaking it down like that gives you that ability to disambiguate. Whereas the model is not always good for disambiguation. And if you think about it, if you go from, I don't know if people have seen a disambiguation, you'd have, for example, a dictionary, and then you'll go into a data model, and from a data model you'll go to a taxonomy and a thesaurus and an ontology. Those are levels of disambiguating where you're getting more clarity of meaning. So you're getting more clarity of meaning when you get to a concept model or an ontology. Okay. Okay. All right. We'll go through that one a little bit more. So these are the definitions that they've provided, but what I wanted to share with you is, please notice that there is a difference between a concept model map and a conceptual model. They are not the same. Okay. It's always a concept model is always literally expressed by a set of definitions, each definition representing a concept. And then all the connections between the concepts are verbal concepts expressed by verbs or verb phrases. Okay, so it's helpful to have the language definition there so that you can actually see it. And when you get into logic, you can now validate that your model is correct as soon as you step down into or get to that logic definition. Okay. All right. Now we're going to a conceptual model, and I sort of don't want to read out everything. There's the definition from Copilot, from Wikipedia. And a conceptual model refers to any model that is formed after a conceptualization process. So conceptual modeling delivers the output of a conceptual model. Now, a concept map is input to the conceptualization process. And this is where we start creating these dependencies that you would like to get resolved. And it's nice to have that ability to have a SME there that's with you on your data modeling. So whilst you're building it, if you don't have something well defined, you can then get the clarity that you're requiring. Okay, so here's just a difference between conceptual versus concept. So what's the core purpose of the model, a conceptual model? That's to initiate engineering. Okay, so we have a conceptual model or the design, and that's, remember in the Zachman, where we go from architect to engineer, that would be the logical model step. Okay, that's when we initiate that engineering. All right, so this is the conceptual model, and as a concept model, it's to create an inventory of defined words. So this is your word model. Okay. All right. So what is the target of a conceptual model? Okay, some capability which can contain inventories, processes, locations, and I'm going to show you how I map that to the Zachman framework. You guys probably start linking all of that. Remember, the what column is the first column on the left of Zachman, and then it goes to processes, and so the how, where, who, what, and why right at the end. That's the target that we're getting into. Okay. What are referenced in the model? Okay. Often in the real world, it contains references to the real world. Okay. In a concept model, this is always in people's head, and that's what we're trying to do, is we're trying to get that understanding defined. Okay, and then we can bring that representation of it as a representation of the real world. So what form does the model take? Usually graphical. Okay, a concept model, always definitions, taxonomy, structures, structural statements. You can illustrate it as a graphical diagram, and I'm going to show you some examples, but that's typically definitions. What kind of connections does the model feature? Structural, sequential, spatial, collaborative. And please, this conceptual model, please don't restrict it to a data model. It can also be an architectural conceptual model of a system or an infrastructure. So it's wider than just a data model. Okay. What kind of engineering does the model address? Basically any kind. It can be software engineering, it can be data engineering. Concept model is only knowledge. Okay, that's directly, that's the target, is our knowledge and our understanding. Yes, Paul.
Just on your previous statements, I wanted to say the conceptual model that we're building for AGOF, we try to build the conceptual model for their what they call alignment framework app. Now, I haven't worked at an organization ever that actually thinks so deeply about their purpose and about their desired outcomes.
Oh, right. Yeah.
In fact, not only Alan Gray Orbis Foundation themselves, but the bigger philanthropy group. And we started with the conceptual model in Ellie with, as we typically do it, we just actually have the words down, try to define them and try to relate them. And it was so complex that we had a few sources to look at. So they have they got like a consulting firm helping them with their organizational strategy, and they have very good infographics about their BHAG, and their milestones all that. So if you look at the infographic, it kind of makes sense, but you put that thing into a conceptual model of any kind, it's like, what's going on here? We can't actually, does this relate to that? Or, what are you actually measuring and whatnot? And so we actually had to revert to, we used Archie, I like Archie, So we did a lot of different models in Archie to understand the various concepts first. So in Archie, what you can't easily do in a conceptual model, what you can do in Archie is, for example, you have types. You have a product type, or you have a you have a role and you have a party and all that, and you can sort of untangle a few things. And we spend quite a bit of time. We probably won't use the Archi models going forward, but we spend a lot of time there to understand the different components. And then when we went to the conceptual model, we actually could create a very clean and simple one. So just to support your idea there, not to really focus on the conceptual model, it's not necessarily become a data model. It should really support the understanding of things on a high level.
Right.
Yeah. So
it's a nice description. It's that what is the purpose, and what is the function that it performs. So it's that disambiguation of the statements of the words.
Yes.
So we have a clear understanding, and we have a common understanding. And I'll talk a little bit about that later on. But yeah, it's I think it's important that we understand a conceptual framework, and it can be applied to anything. That conceptual framework could be applied to economics or whatever it is. It's a model of what's happening or what's occurring, and it can be quite a bit of process and activity work that's going on, and not just the nouns that we tend to focus on. You'll get more of the activity coming through.
Yeah.
Great.
That's and the last thing about, just to support that, is that's why that it's so important to get the verbs on the lines, because then you describe the activities or it's not only a structural concept that you may be trying to present, not a process either, but there is interrelationships that you actually want to capture, right? So
yeah. And remember, when we do the Steve Hoberman training, it's about almost writing down those business rules, those 6 rules and from that we can derive the entities and the relationships and the cardinalities and things like that.
Yes.
That's your concept model. Now, that's why when you look at FCOIM or case talk, that idea of enumerating the facts or defining elementary facts is so important, because from there you can derive a lot of your relationships and your entities and things like that. So, great. Okay, conceptual modeling is the development. There is the classification. It's the development of that high-level representation of a system. Okay, so there it is. Objectives, inputs, outputs, simplifications can be depicted in graphical and causal loop diagrams and activity diagrams. So these things all come together. And then we have Copilot that generated something for me. I like this thing. It's a way, conceptual model is a way of representing the systems, the abstract concepts, the relationships. And the key points is about abstract representation. Please, this is not abstract in terms of typing. It's abstract in terms of simplification and visual representation. And so whatever we put there, for example, the entity called customer, that's not the actual customer. That's just an abstract representation of that customer, the way we think about it. It's a communication tool, user-centered design, and versatility. Okay, I will share all the slides with you so you can get all of that. Now, bringing this all together, this is the sort of path that we walk through. Okay, so if I look at classification, a conceptual schema, it's an ideas drawing. That's what it is. Okay, a concept model is a set of definitions or logic. So please remember, when you get to logic that Maria Kent was talking about in terms of inferences and things like that, can you see there we're getting the definitions right? Then we get conceptual modeling is the activity, and then it delivers something called the high-level representation. And the last step is, finally, it's a high-level database description. So we're going round in this circle in this iterative approach. First of all, to find our classifications. Then we have a purpose statement. Easy to understand, clear communication, disambiguation. Okay, can you see the concept models there? That's much stronger at disambiguation than the conceptual model. Okay, helps common understanding, aids in communication, helps understanding, focus without details. Okay, The conceptual model. It's getting me to focus on things that are important, and I do not need to go to the details at this point in time. Okay, what is the what part of a conceptual schema? It's the ontology of concepts. Okay, it's the concepts that exist in our problem domain. Okay, it's that controlled vocabulary. Okay, it's an inventory of words. It's a controlled vocabulary or a universe of discourse. That's what we are talking about. Okay, that's what the concept model. Then we have the conceptual modeling, which is the act of creating a high-level representation. And the conceptual model is an outline of the main components. It's not everything. And I wanted to stay away from abstract because we can get into all sorts of challenge or misunderstandings around the term abstract. Okay, so that was the terminology. Are there any questions around that reflection of the critical terms in conceptual modeling? Does it bring some clarity? Is it helpful? Great. Okay, thanks, Brian. Okay, so let's look at conceptual modeling, the concept map. Okay, and who do we go to? We go to Mr. Zachman. Okay, so remember I said the first column of Zachman, and I also refer to the Zachman ontology or framework as almost the periodic table. It's the list of elements that we have. Okay, so that's why I like to use, I don't like to just focus on TOGAF, which is about processes and procedures. I also like to use the ontology, bring them together, and that gives me both my periodic table and my transactions or my reactions. Okay, so here's Mr. Zachman, the what of data. At the executive level, it's a list of entities. It's your subject area model, your data estate. Okay, then the manager refers to conceptual data model, the logical data model. Then we go into engineering. Then we go into the developer or the DBA. That's the data definition. And then we go into data instances. Now, what's important about Zachman is please don't think you're just going from vertical all the way down. At each level, you also need to go horizontal. So the conceptual data model will then build a function model that collects and aggregates and CRUDs the data. And then you have logistics around the functions. You have roles and responsibilities. You have a schedule, and you have a business plan. Okay, so can you see how they develop? Okay, we're going, not only are we going down on the vertical, we're also going horizontal. Okay, so important to recognize that in terms of coming where we come down. So just to bring that out a little bit more, here's the ontology. So we have for an inventory identification, we have the operating model or the subject area model, and that gives us our executive perspective. Okay, then we have the conceptual data model, and then we have the business management perspective, and so we go developing all of these at the same time, and this would be to build a complete system. Okay, so you get the data model out, and then you go into the process definition, distribution, responsibility, timing, and motivation. Okay, the last column there is always your why model that's giving you your why elements. Okay, so here's an example of a concept model. So I've done a concept model for conceptual modeling. Okay, and so the goals: clearer insight into the system, communication and analysis. Okay, how do we analyze what we have, and how do we look for potential improvements? It's not always easy to go and look at all of the Excel spreadsheets or the data or the databases to start looking at improvements. Yes, you can certainly bring that as input, but it's sometimes quite easier, a lot easier to work at the conceptual model. Okay, the entities that we have, the processes of identification, abstraction, representation, validation, and then the tools that we use. So that's a concept model that you can bring together. Okay, so you're trying to have simple statements and definitions of the areas that you're working in. Okay, now this comes into an ontology for data modeling. Now, if you're aware of it, remember an ontology can be expressed in a machine readable format. So it can be an OWL, and that's how you get your knowledge to your knowledge graph, is when you add to a property graph where you add a ontology to that. Okay. So here's an example of an ontology for data modeling. And this can be, remember I said there could be a visual representation of a word map, and this is an example of that visual representation. Okay, so that's data modeling. That's the important thing. Now, what we do as trainers when we have to train people, and certainly Veronica can relate to this, is Veronica, you're going to have to go and explain to people what is an entity, what is an attribute, what is a relationship, okay, and the data properties and the relationships and the constraints. So these are the things that you need to explain to the people before they can start data modeling. Is that correct?
Yes, they need to know the building blocks.
They need to know the building blocks. Okay, so that's almost that concept map. So before we can do conceptual modeling, we need to understand the building blocks. Okay, and what are the building blocks and how do they relate to each other? Okay, great. So then just to go through data modeling as an overview, just a quick overview of it. So remember we have the levels of data modeling. Conceptual model and subject area model, they break down into a logical model. That's typically at your enterprise data model. And then for your application, you can have both logical and physical. And I've even seen quite often that you have a conceptual model. So you can have a CDM, an LDM, and a PDM all for an application. Okay. And then this is how you break it down from a subject area, for example, product design or commercial offering or sales subject. Here we can look at the high level concepts, the abstract concepts or the simplified concepts that are part of the product design subject area. Okay, and then we have some level of relationships between them. Those are the verbs. So a product belongs to a product group. Okay, and reading it the other way around. So there's a single product group. A product group may contain multiple products. And so we would go and read all of these different areas. Please, can you also see that you have these crossovers of elements? For example, sales item relates to a product, but a concept cannot be in multiple subject areas. Okay, so remember that MECE, and MECE, that's MECE, which means mutually exclusive, collectively exhaustive. Okay, so mutually exclusive is saying that a concept cannot belong to multiple subject areas. This is quite important. I'll just share with you, someone came to me saying, are they really battling with their business glossary? Because they believe that certain SMEs saying party or address, why are we defining it? That should be a common term, and then we should have the data governance team defining the common term. I said, probably what you've got wrong now is your subject area model and your ownership, and you need to get that right even before you start with the business glossary and terminology definitions. Okay. All right, and then the last thing I wanted to just show you in this one is it's this situation of we have data modeling schemes, relational, dimensional, object-oriented, fact-based, time-based, and NoSQL, and they relate to areas in data storage. So if our target database, and we also have to choose that, is, for example, a relational database, well, then it's no use. Oh, shucks, I missed some animation there. I should have lost this diagram over here. Let me see if I can do that quickly. Sorry. Are there any questions whilst I'm just fixing this slide?
If we do have questions, we are going to make you do multi-fail.
Okay. No, I'll survive now on this one. Okay, so what this is saying, and I've seen so many people when they read the DM is saying, what is this diagram all about? It's driving me crazy. Okay, what it is saying as an example here is that if you've chosen a NoSQL database, okay, you should not be trying to put that into a relational database or a multi-dimensional database. So NoSQL is the physical implementation. It will derive itself from a logical data model. So for a object database or a document database or a column database, you will have a conceptual data model, you'll have a logical data model, and then you will have the appropriate physical data model for the column database. Similarly with a graph, similarly with a key value. So I'm hoping you're seeing here that the conceptual model, the conceptual data model, is applicable to all storage types. Okay, it's required for all storage types, and even the logical data model is appropriate. It's just the physical data model where we see these differences. Okay, and then when you get into time-based and NoSQL, you're now talking physical representations or physical data models. Okay, so that's pretty much what that diagram is saying, and it's important to understand, well, what schema is the most appropriate for this business problem that I'm trying to deal with. Okay, that's one of our data modeling scorecards, is choosing the right schema. So let me have a quick question here. If you were building a database that needed to model the business rules, what schema would you use? Or maybe what schema would you not use? Would you mind if I picked on you, JG?
So Howard, for me, a business rule would be relational by nature. It's kind of sequential. It doesn't have much. There's not much ambiguity. You start in one point, go to another. That's the important. So to answer your question, I would use relational. What maybe I'm confused about is I would then use a dimensional model to aggregate my transactions. So maybe you can just help me. Well, so I feel like I could have used dimensional, but that's not so much the model. It's more of a way in which I would aggregate the relational.
Yeah. So what we're seeing here is, first of all, when you're trying to achieve, for example, something that will help business make a decision about the facts that they have. The first thing you need to do is choose the right scheme for what you're doing. Now, as you just pointed out, you're 100% correct. If I was to ensure the integrity of the business rules or the business logic, I would choose a relational database. That would be an entity relationship model. Okay, that would be the right scheme. If I wanted to work with aggregation of facts, I would not choose relational. I would choose a dimensional model in that, and these would be the typical storage databases that I could be as the target system. So if I wanted a dimensional model, I could either target a relational database or a multi-dimensional database. I wouldn't look at a document or a column or a graph for a dimensional model. So the business problem will dictate the schema. The schema will probably dictate the database that you use to store the data in. JG, does that answer your question?
I mean, it does, Howard. It brings up another question, which is, so there's a blank between dimensional and document, right? So the intersection of dimensional and document. So if I have a data structure that is kind of XML by nature and
that's your document.
Yeah, but it contains a set of measures that I would very much like to aggregate by.
Yeah. So
does that mean I have
to
flatten it first?
Yeah, you'd actually they call it materialize. So you would flatten it, you would take the data out of the XML document, put it into either a relational or dimensional database for you to be able to understand the elements in that. And that's what's happening with so many of the NoSQL databases, is that they have to come out of their base structure into a relational or dimensional structure to start the analytics. Does that make sense, JG?
Yeah. No, thank you.
So people refer to it as tabular, or structured or non-structured. So basically your NoSQL is in a document or a column or a graph. Now, I'm not saying that for a graph is actually good for inference analytics, but it's not good for aggregation or counting or things like that. So you would then go into a more of a fact table or dimension table to do the task that you're trying to achieve. Okay.
Thanks, Howard.
Great. All right. So let's go to.
I got one question.
Yes.
Yeah. So Howard, I wanted to understand. Let's say the physical data model, the ask is to have in the dimensional as per the business need. So is that fine to have the logical and logical model as a relational model?
Okay, so no, and that's something we do train if the business would like to have to have a set of questions answered, so they want to analyze the data, then they would build a logical dimensional model, not a logical relational model. So you'll find that those two don't mix. A relational model and a dimensional model should not be in the same model. So you wouldn't try to put a relational model and a dimensional model in the same logical model. It tends not to work. Was that the question?
No. Thing is, Howard, let's say business later on, keeping logical model as a relational way would help us to later on to cater all the solutions. Let's say it would act as a conformed layer or a reusable structure, right? But a dimensional model won't work as a reusable structure later on if we are creating the logical model as a dimensional model. Correct me if I'm wrong.
All right, so I'm not sure I fully understood what you're saying, but let me try to repeat. And let's almost take an example of using a data warehouse and a data mart. So yes. The data mart is your dimensional model or your self-service BI, and your data warehouse, and not a Kimball data warehouse, but a Inmon or Data Vault data warehouse is more of your third normal form relational model.
Yes.
Okay. And you don't want to mix those models. So of course your source model for your dimensional model will typically be a relational logical model, and then you'll change it to a dimensional logical data model where you model the hierarchies and the navigation paths to your fact table. So your dimensional model sitting in these two areas is very different to the relational model. Yes, it can live on a relational database, but it is modeled differently.
Yes.
Did I answer your question properly?
Yes. Thanks, Howard. Got it.
Okay, thank you. Veronica, did you have something to add there? I saw you. Okay. All right. Okay, so
I misunderstood what she was asking in the first place.
Yeah,
okay.
so What explained correctly, like it is like if we are building for the in-one model, then we can go for this relational and simple, and creating a data mart, we can go for this dimensional, right? Howard?
Yes,
If,
yes.
yes.
Okay. All right. So now let's go to for the data manager. So the data manager, the person who's either heading the data management office, the DMO, or the EIM department, or whatever it is, they have some serious challenges to bring this capability of conceptual modeling, data modeling into the organization. And these are the challenges they face. First of all, stakeholder alignment. Then it's about getting the right implementation framework. Then it's about ensuring scalability, and then it's about data integration. These are what I believe are the core challenges facing the data manager. Okay, so let's talk through some of them. Shared understanding and commitment to purpose. So what I've got to do before I try to get them to commit to the purpose is I've got to try to establish shared understanding. Now, I'm not sure if you remember, if you do the change management or the ProSci framework, you have that ADCAR, and I turned off. So let me just quickly turn that on again. The chat. Okay. Who can tell me what ADCAR stands for?
An advertisement for a car.
Nice, Gigi. So ADCAR,
Aware.
that's
desire.
right. There's ADCAR that's in the chat. So aware is aware. A stands for awareness. Okay. D stands for desire. Do people want to do this data modeling, especially when they see what they have to do? K stands for the knowledge. And basically what it says is, please don't start training people if they have no awareness and no desire. And for the data management, when you talk about change management, please don't try to force them to sign the policies and procedures or work on that thing before they have an awareness or a shared understanding. What is conceptual modeling giving us and how do we benefit from it? Then you'll go for that commitment to purpose. Okay. So we got to get the awareness right and the desire. The desire, the important thing about desire is that what is in it for me? Okay, that's the important one, where they've got to acknowledge that they want to do data conceptual modeling. Okay. Now that would be all about how does that help me with my decision making? Okay, so to get the awareness right, or that shared understanding, we would need to go to these terms. Okay, and what I'm going to try to bring about is the disambiguation. So it's really nice to be able to go into an organization and find the war story about the way in which the KPIs were interpreted differently and reported differently, and then they got different results because of the lack of common understanding or an agreed definition, or it has not been appropriately disambiguated. Okay, we don't have the words defined properly. And I always remember Steve Hoberman, and I think he shared it in his last one, where he's focusing a lot more on getting the terms defined. As Veronica said, he went into a business, he had to go and present to the executive board or the CEO, why do we need to have data modeling? Okay, so that's this awareness thing. And so the first thing he did was he actually asked the people around the table, I think there was 8 or 9 people, to, on a piece of paper, quickly define what the term customer meant. And I think he got 4 different definitions of the term customer. And when the CEO read all of these different understandings, he says, okay, I get it. I now understand why we need data modeling. And he then had the desire. So you'd see that transformation from desire, from awareness, first of all, from no awareness to awareness and then the desire. Okay, so that's That's the way we need to do it. We need to be able to explain what are the critical terms and what is it all about. Okay. Now, let's just, once you've got that, then we need to talk about getting this commitment to purpose. And what I wanted to just share with you is the first step is common understanding, i.e., we have more than one person agreeing with that. Okay. And the target state is to be found in large numbers in your organization. You all have a common understanding of that situation. So it's a mutual understanding. Now, a shared understanding is it's used by multiple people, used by multiple entities, it's used for multiple purposes. For example, a data conceptual model, a process conceptual model, that's typically your capability map is a conceptual model of the processes. And then you have an application conceptual model. Okay. And then ways, that's behavior. How do we behave? That's also used in multiple terms. And the final purpose is this disambiguation. And what I would like to say is one of the terms that I've looked at, especially in my metadata, is getting the vertical lineage right before the horizontal lineage. Okay. I promise you, when you start looking at data quality issues along the horizontal lineage of where the data moved, you are then so desperate to have some form of conceptual model that reflects all of the data as it goes along the horizontal lineage. And one of the things that ISO 8061 dictates is they call it state reconstruction. Describe the processes that created the data. And so you're lifting from the database all the way up vertically along the Zachman framework. Remember that Zachman data instance, data definition. Then we talk about the different models. He's saying get the vertical right, and then you can understand the horizontal. Okay. It's not easy to understand the horizontal when you don't have the vertical. Okay. All right. Now, the other thing that the stages of conceptual modeling, so I like to describe it like this. First of all, problem description, then project goals and conceptual model with clarification using the concept map, refinement, verification. And then we get into, if we could, in terms of verification, it would be nice to have either simulation or a digital twin. Okay, so we can simulate the program, check to see whether we've established credibility. Does it resolve our goals, experiment, and then we got a problem, go back, modify the problem statement, and go around in these circles. Okay, so this is how you can verify a data model. Have any of you been involved or exposed to a digital twin? Does anyone know the difference between a digital twin or a simulation? JG, you did a lot of this. You did a lot of this in Aris, I believe, or you did a lot of simulations in cargo or third-party logistics, right?
Yeah, that arena, but I can't say that I ever took this approach. We were just desperately trying to solve a problem in the mill, but
a scheduling problem, right?
Correct.
It was a scheduling problem of people coming through the gates, if I'm correct.
Yeah, it was a challenge where one mill had bought another one. So historically they were in competition with each other, and then overnight it all of a sudden opened up an opportunity for optimization, because now the mill was no longer in competition. They were now
right.
And so, but I definitely didn't try and put a digital twin in place.
Okay.
Maybe Arena did. Maybe Arena did.
Do you know what a digital twin is?
I would say no.
Okay. It's I don't know how many. It's been going on since smart cities came out. They created these digital twins. Now, the first time I experienced a digital twin was my dad, who was a civil engineer. They wanted to build a telecommunications tower in Pretoria. And they knew that one of the problems with Pretoria was the wind. As it came through the different mountains, it would funnel. And they felt that if they built this telecommunications tower, it wouldn't last and it would break. So they created a simulation of that in terms of, depending on the structure of the tower, would it fall over and what sort of high winds could it tolerate? So the civil engineers have been doing this simulation model for quite some time. And I remember him showing me through this in terms of how the design changed from the way they did normal telecommunication design to the way they built the tower in Pretoria. Okay, and they had to allow for the wind to come through the tower in Pretoria so it didn't create this fixed structure that would be blown over. Now, so what you get is you get the simulation, and they try to simulate all of the possible effects and blocks and cues and things like that. So they were trying to understand how this model would respond. A digital twin takes this a level further, that it actually puts these sensors into the actual smart city. And yes, we get the initial design, but then as the system is operating, it's also getting feedback. And as the feedback's happening, it's also then getting into prediction and elements like that. So it almost becomes a real-time simulation of, and that's what a digital twin is. So you would implement it, you would have sensors in a smart city, everything's coming along, and then you would have questions like, oh, can I optimize the energy usage? Can I switch off this? Can I switch off that? Do I produce more energy? Whatever it is. And that's what a digital twin, the role that a digital twin is playing in smart cities and big areas that you're working on. Okay. And these are the artifacts. And then when we get into framework, so this is, as an example, these are the principles of conceptual modeling: abstraction, representation, consistency, clarity of communication, relevance, purpose, limitation. Don't over-engineer, over-scope or under-scope. Scalability. So this is about lossless model extension. How are we able to extend the model without losing elements? And then validation. How do we validate that this model can meet the requirements? Okay, how do we do that? I've mentioned simulation and digital twins, but you can also use ontology logic. The ontology is really good for validating the logic of the system that you have. Okay, this is what would make up a policy. Okay, these are the elements that you'd have to have in your data modeling policy. Okay, and then this would be an implementation framework. What is the implementation framework? It's a sequencing of procedures that you need to build. So there's align, refine, design that comes from Mr. Hoberman, and then that's fine, but then you need to validate it. And then you need to implement it, you then need to maintain it, and then you need to evaluate it. Okay, so that's the extension of the implementation framework. Steve Hoberman was really just focusing on the process of modeling, but where we have to keep going is the implementation, the maintenance. So what happens when the developer needs a quick change in the table? Where does he go to? Does he just go and change the database, or does he have to come all the way back? Okay, and then evaluation on the different areas. Okay, so scalability of meeting the needs that the business have, and then the 3 Vs. Can your conceptual model deal with a variety of data, the volume and the velocity? Okay, those are important questions. Integration, how do we integrate multiple data sources? How do we unify everything together? And I just wanted to show you here that that's what that canonical model is all about. And an ontology. That's how we're getting these integrations to happen and to come to a unified model. And ontologies are having tremendous success, specifically in the GO project, okay? And gene ontology, where they can bring it from multiple systems, are populating gene and biomedicine information, and then they can integrate it using an OWL or an ontology. Okay, they can bring all of these data together and they can automate the integration. Okay, so key modeling takeaways, understand the benefits. All right, How do we align data structure to business goals? That's what we were talking about with JG in terms of that problem definition, business objectives. Provide the focus, core concepts, core relationships. That's what we got to get. Guys, this is what the system has to do. And then the business glossary. Business definitions, business rules, and term relationships. There's the benefit that we get out of our conceptual models. Okay, and so here's just a view of the different data models that we work with. Now, how do we apply this to data governance? Okay, I'm just bringing this slide here because probably you guys have forgotten it. This one about setting up the operating model, and look at what's happening down the bottom here. Here's our subject area model. Okay, now so many times people go ahead and they just say, all right, let's just appoint data owners. Okay, guys, that's great, but what is their area of responsibility? How do you delineate and you delineate and you don't have two owners responsible for the same thing or some data not having a responsible party? You use your subject area model. Okay, so another big benefit of conceptual models is getting this sorted out. Okay, now I wanted to just show you basically the steps that we use coming all the way from business architecture. And this is how we set up an information management program. From the business architecture, we get the value drivers. We then get the business strategy. From the business strategy, we have our capability map. And from the capability map, you get your data subject areas. Once you've got your data subject areas, you can build your data strategy SWOT of what are all the problems that business are having with their data. That's why we refer to it as a data strategy SWOT. Okay. From there, we can see the heat map of data strategy. We got problems here. We're okay there. We're sensitive in these areas. We build a heat map of the data. And then we would build a capability map for data to be able to address the challenges we're seeing here. We then go and define an operating model, and then we allocate ownership. And this is basically where data governance begins. So we need to get this all set up before we start with our data governance program. Okay, so critical is the conceptual subject areas. Okay, so that's the flow through the system. Be careful of missing this step. In business architecture, they refer to this as the information model. Okay, you need it. You need to get it done so that you can focus on your strategy and then get your heat map with what are the things that you should be focusing on to address. Then you build your capability, your operating model, and there we go down the road. Are there any questions on that? Anything that anyone would like to ask about? Where does the conceptual model start and relate to business?
Howard,
Yes.
Is your conceptual data subject areas, is that what was that historically referred to as a data estate?
Yes.
Cool, thank you.
And remember, JG, we actually derive the data estate or the subject area from the capability map. So we look at the nouns and the verbs in the capability map: plan, market, policy, capital, message, business entity, information, product, customer, agreement. Can you see all of the nouns that are quickly coming out that form your data, your subject area or your data estate?
Yeah, thank you. I see that.
Okay, now it's nice to work from this map. Why is it so nice? Because you don't get into all sorts of fancy aggregation. Now already you can see here, someone created party, and you're going to say, oh, there's some challenges there. Should it be called party or should it be called customer? Now, the problem they have with customer is that it can be a client, a wholesaler, a firm, an employee. And so in some cases, you have challenges in that area as to what to call them. Okay. And then you want to link your priorities with your heat map. You want to link your priorities to the work that you need to do. Okay. All right. Then the next thing you want to do, and how does this help your data governance? First of all, by understanding the data, what data do we need? Okay, so there's an example of what data we need. This is the data that we need, and then what data are we having problems with? Okay, so what data do we need? Okay, that's that step over there, and it's linked to the processes that are going to create the data. Okay, and why do we need it, and who's going to create it? There's what data do we need? Then do we agree on its meaning? Okay, definitions, concept models, glossaries, data models, conceptual models. Do we know its location? Okay, there we're going down to the horizontal, we're going down in terms of the Zachman one. We're coming down to where is the data cataloged and where does it reside? And then do we have the right people? And then is it fit for purpose? Does it have the right quality? Okay, so data governance, you need to be able to answer this about any piece of data that you have. And this is your core focus is what do we need? Does it have the right meaning? Where is it located? Do we have the right people having access to it? And then is it fit for purpose? Okay, a summary of data governance in one slide. Okay, and then we get to communication and change, common understanding for communications. Okay, and then shared behavior. How do we achieve that? Build an implementation framework and then build knowledge management around these areas. All right, and that's, sorry, I took way longer than I expected. Are there any questions, any comments, questions?
So how are we going to get this recording or these PPTs?
Yes, you will. You'll get the recording and the PPTs, correct.
Via email?
What we do is we go through an editing process, and then we publish a post on LinkedIn. So please connect with me on LinkedIn. When it's ready, we'll notify everybody, and then you can, on that LinkedIn post, you can just say, can I have the presentation or the video recording or whatever it is. You'll get, or you'll be able to request it from there.
Okay, thanks. And other question now, what, like, are we going to have any long-term sessions, any like for this data modeling, like if we want to take?
Yes, certainly. We do have a course running at the moment that focuses on relational and dimensional modeling, and we want to now extend that to the other areas that we shared there, those other ones that we talk about in terms of fact-oriented, time-based, and NoSQL. We want to extend the modeling to deal with those as well. And then moving into the semantics, that ontology. How do we build an ontology that will help? Because an ontology is like it's a concept map, so it almost should come before our data modeling.
Yeah. So, like, can I have those details, like for those course, like if I want to?
Certainly, I'll get. If you could, I think Debbie. I'm not sure if Debbie, are you there? If Debbie, have you got your email address? Okay, I'll put Debbie's email address, and you can send it to her. Send her a message, and she'll get back to you.
Yeah, sure. Let me put it.
There it is. And or if you want to put it there, then we'll contact you.
Yeah, sure. Yeah. Thank you. Thanks.
Yes, Veronica, see your hands up.
I just wanted to remind everybody that what Smita was saying is this it. This is not it. Next Thursday and the following 2 Thursdays, you're going to get more of this. How it's he does the 4 weeks where he builds on each of his different topics. So if you enjoyed this one, you've got 3 more Thursdays to attend.
Right. So this is Data Manager was this week. Then we will be doing Data Citizen next week. So we'll be taking the same topic and talk about how do we read the models, how do we build the models for data citizens, how do we get non-technical people to adopt the models and trust the models, and how do we use the modeling in decision making. Okay, and then the next one is oversimplification or balancing the need for simplicity with the complexity of model data. So there's lots of challenges that you face in that area. And then this is for the data professional. There's all sorts of different types of schemes and notations and data quality and self-service analytics and wide data. Those are all the challenges for a data professional, and the data executive has these challenges: strategic insight, decision-making, and business alignment. How do they make sure that that is correct? Great. Mr. Bolton, any questions from your side?
No, Howard, I think just coming off the back of this week with the training and fundamentals, just awesome, another level of learning. So I'm just like soaking it up. It's like nice.
Okay.
You know, like one of the things that happened on the course is there's some people that were experienced, and you can hear the way they explain something, they jump steps automatically, and it's not wrong, because it's just they've done it so many times. It's normal for them, so they can go from A to Z quite quickly. And but it's taking the deep dive into those finer steps that really help understanding and build that knowledge, and takes you a step closer to the ability. So for me, where I'm at, that's just awesome what I'm seeing here. So thanks, it's awesome.
Cool. Pleasure. And we will get into normalization for a data professional. We're going to talk, and I don't know if you're aware, Paul, that there's actually six normal forms. So there is a sixth normal form.
Excellent.
And anchor modeling is the sixth normal form. So to answer your question, I'm sure you saw my PowerPoint.
Yes.
There's that third normal form where things are normalized. Then you go into fourth, and you're starting to deal. Fourth is starting to break up those complex association tables with multiple keys.
Yes.
Multiple keys. And then the fifth normal form is about understanding relationships between those multi-association tables that you broke up. So fourth normal form creates another level of association table, and then fifth normal form is about understanding the relationships between those.
Yeah, thanks, man. Yeah.
But you actually need a good example to see what type of knowledge you get from normalizing.
Yes.
Because lots of people see normalization as a pain or a theoretical concept. I see it as knowledge engineering or knowledge discovery. I'm finding out a lot more about the data and the entities and the relationships. That's what normalization is doing for me.
No, awesome. Thank you.
Cool.
Awesome.
When do you fly? Soon?
Not soon enough.
Yeah, okay.
It's at 10 to 4 in the morning. So I'm gonna just kind of do some Netflixing in the hotel, cool. And then I'm gonna shift at about 11:30. Yeah. So
travel safely.
Thank you so much. Safely. Cool, guys.
Any other question? Anybody else have any other questions?
No questions, Howard. Just say thank you. It's been insightful, and look forward to this course and hopefully build on my knowledge. So
thank you very much, Bill. I appreciate that. Thank you, sir. Thanks, everybody.
Cheers. Thank you.
Thanks. It was
awesome. Thank you very much.
Thank you so much. See you tomorrow.
Yeah.
Bye.
Bye-bye.
Happy holiday.